All right, so today we're going to be looking at lesson 19.2, dealing with the geometric mean. So this is a continuation of what we looked at in the previous lesson, but this is going to show us a slightly different way to work through these problems. You may prefer drawing the three triangles like we did in the lesson previously, and if you like that method, you're welcome to continue doing that method. This method that we're going to look at today is just a little bit quicker if you have the rules memorized. So it does require a little bit of memorization. And so we're going to start off here. Which two similar triangles allow us to show that x over t equals t over z? So what you want to find, what are the triangles that have those side lengths? X and t are in this little triangle, and t and z are in the medium-sized triangle. And so if we write our similarity statement, triangle AES is similar to triangle YAS. So then it asks which two similar triangles allow us to show x over u is equal to u over p. So what we're looking at here, x and u are in this little triangle, and u and p are in this bigger triangle, because the p is the whole hypotenuse of that large triangle. And so the statement that you can write there, triangle AES is similar to triangle YEA. So now we're going to be looking at two corollaries related to the right triangle altitude theorem that we looked at in the previous lesson. So a corollary is kind of like a sub-theorem. It's just related to this theorem. You're going to treat it just like it's a theorem. It's just called a corollary because it follows directly from another theorem. So the first corollary, when your altitude is drawn to the hypotenuse of a right triangle, so like what we have in our figure, when that happens, the altitude is the geometric mean between the segments of the hypotenuse. And so some of you may know what the geometric mean is, and some of you may not. So I want to go to the next page in your notes and discuss geometric mean, and then come back and go over this corollary in more detail. So if you look here, the geometric mean of two positive numbers a and b, your geometric mean is going to be some number x. And you set up this proportion. So your geometric mean is x, and then your two numbers are a and b, some random two positive numbers. And so when you cross multiply, you would have x squared equals ab, and then you would take the square root. And so that's what you do when you're looking for the geometric mean. So they tell you 6 is the geometric mean of 4 and 9. And so what we can do, if we know that 6 is the geometric mean, we put it diagonally. If you would rather do it like this, you can. It doesn't matter. Either one would work. And then it says it's the geometric mean of 4 and 9. And so they go in the other spots. And you can do 4 and 9, or you could have done 9 and 4. It doesn't matter. They can be switched. But that's how you would set up something related to the geometric mean. So just for those of you that are interested, if you're looking for the geometric mean of more than two numbers, so let's say we were looking for 4 numbers, 24, 42, 49, and 63. Your geometric mean would be to take not the square root, but the fourth root of those numbers multiplied together, the product of those numbers, which is 42. It just so happens to be one of the same numbers. It doesn't usually. But your geometric mean is just you take the square root of 2 numbers, or the cube root of 3 numbers, etc. The nth root of however many terms you have. So now let's go back to the corollary. So look in here. The altitude is the geometric mean between our segments of our hypotenuse. So if you look at that figure that they have at the top of the page, our altitude is given by t. And so we could say t is our geometric mean. And then the parts of your hypotenuse are x and z. And so x and z would go right there. So that's how we can set up using that corollary. So if you just want to look at a triangle that only has those parts. You could put A and B and C, something like that. Your altitude is your geometric mean between your two parts of your hypotenuse. So that's the first corollary. The second corollary also talks about geometric mean, but this time, when you have your altitude drawn, like we do in your right triangle, each leg is the geometric mean between the hypotenuse and the part of the hypotenuse that is adjacent to the leg. So let's look. U is a leg of the larger triangle. So U is the geometric mean, and it's a geometric mean between the hypotenuse. The whole length of the hypotenuse is P. And the part of the hypotenuse that is adjacent to the leg that we were looking at is X. So X and P are our two numbers that we would use. You could do the same idea with the other leg, W. So W is our geometric mean between the whole hypotenuse, P, and the part of the hypotenuse that is closer to the W, which is Z. So that's the second corollary. So if you want to look at a figure that just uses no altitude is given, you could set up D as our geometric mean. It's a D. Between E, because that's the part that's closer to it, and E plus F, because that's the whole hypotenuse. So if they don't tell you the whole hypotenuse, you just add those two parts together. Or likewise, F over G would equal G over E plus F. So, like I said, you do have a little bit of memorization to go with this method, but if you prefer it, absolutely acceptable to use it. It is definitely going to be quicker than drawing the three triangles like we looked at in the previous lesson. So in item 2, what we were just looking at, we use properties of similar triangles to justify that we could say X over U and U over P. And we want to solve that proportion for U. So if you cross multiply, you would get U squared equals X times P, and then you can take the square root, and so U is X times P or P times X with the square root. So you could even, if you know you're looking for your geometric mean, you could even just put your numbers and multiply them and take the square root. You don't have to even set up the ratio if you would like. I typically set up the ratio, but that's up to you. So now we want to write and solve the proportion that can be written from corollary 2 using W. And so that's actually what we have right here. So P over W equals W over Z. So then if you cross multiply, I have W squared equals PZ. And so then take the square root, and you get that W is the square root of P times Z. So that's how you could find W. So now let's look at the next page. They give us an example. So we have a right triangle with altitude FG. So that means that we have 3 similar triangles. And so they walk us through how to find X, given that Y is 9 and Z is 36. And so if you want to look at their work, you can. I'm going to try and explain it. So we're looking for X. We don't know what X is. We know that Y is 9 and Z is 36. So this is our altitude. Our altitude is the geometric mean. So when I go to set up my ratios, I can put X in its geometric mean location. Then it's the geometric mean between 2 numbers, 9 and 36. And so I place the 9 and the 36. If you'd rather put the 36 here and the 9 here, that's acceptable. Cross multiply. You have X squared equals 9 times 36, which is 324. And then you take the square root, and you get that X is 18. So that'd be if you were given Y and Z looking for X. Now, part A and B at the bottom of try these wants you to use some different numbers. So we're still using the same figure, just different numbers. So this time it says y is 2 and x is 16. And we don't know z. We are looking for z. So I know that my altitude is my geometric mean. So I can set up my ratios. 16 is my geometric mean. And it's the geometric mean of the two parts of the hypotenuse, which are 2 and z. And so I can cross multiply. 2z equals 256, and then divide by 2 to get 128. So that'd be the length of z. Does it look like it's drawn to scale? No, that's okay. So that's how you could find that value. For part B, they tell us x is 18 and they tell us z is 45. And so now we're looking for y. So again, the altitude is the geometric mean. So I can say 18 for my geometric mean, and then it's the geometric mean of two numbers, y and 45. And so if I cross multiply, I have 45y equals 324. And so then divide by 45 and you get 7.2. So that gives you a couple of examples of how you could work through using the geometric mean here. So going to the next page. They want us to explain how to use the corollary on the first page of the lesson to find Jm, and then find Jm. So let's look. Jm is the altitude. So we're going to use the first corollary to find Jm, which is the length of the altitude. So let's do that. Our altitude is x. So x is our geometric mean, and it's the geometric mean of 12 and 48. So then all you need to do is solve for x. So cross multiply. X squared equals 576. Take the square root, and you have that x is 24, which means Jm is 24. Looking at number 6. All of these are using the same figure, and they're all separate questions. So you're not doing based on A, then I can find B. Like, there's 3 separate problems. They're just using the same figure. So let's look at A. They tell me that x is 4, z is 9, and I'm looking for t. So my altitude is my geometric mean. So that means that t is the geometric mean, and it's the geometric mean of the parts of the hypotenuse, which in this case are 4 and 9. So when you cross multiply, you get t squared equals 36, and when you take the square root, t is 6. Okay, now let's look at part B. So again, same figure, but this time x is 6 and t is 12, and we're looking for z. So my altitude is my geometric mean. 12 is my altitude. So it's my geometric mean, and it's between 6 and z. Geometric mean of 6 and z. So when you cross multiply, you get 6z equals 144, and then divide, and you get that z is 24. Now let's look at one more. Looking at C, they tell us z is 18, t is 32, and we are looking for x. So on this one, again, my altitude is my geometric mean. So I can set up my altitude with my geometric mean. And then x and 18 are my parts of my hypotenuse. So when I cross multiply, I get 18x equals 1024. And if you divide by 18, you should get, it's 56 and 8/9, or if you want to make it a decimal, 56.9. And so that would be the length of x. So now let's look at number 7. We want to explain how we're going to use the 2 corollaries that we learned to find Pj. So if you look, Pj is the altitude, and it's the geometric mean between your 2 parts of your hypotenuse, which we don't know either of those right now. We know the total is 34, but we don't know the two parts. So what we're going to have to use is this 15 to start with. And if we use the 15, we can find the length of this small part of the hypotenuse, and then find the piece of the large hypotenuse, and then use the first corollary to find the altitude. So here's what we're going to do. I'm going to label this X. 15 is the leg, and the leg is the geometric mean of the part of the hypotenuse that is closer to it, adjacent to it, and the whole thing, which is 34. So if you cross multiply, you get 34 x equals 225, and so x is 6.6 if you round. So what that means, I know that this part right here is 6.6. Since this whole part is 34, I can subtract 6.6 from 34 and get that this is 27.4, rounded. If you want to use the whole decimal, you can. So then I can use those two numbers to find my altitude, which I'll label as y. So my altitude is my geometric mean between 6.6 and 27.4. And so y squared is going to be 181.2. And if you take the square root for pj, you get 13.5. So that's how you could use both corollaries in one problem. So now let's look at some of the practice questions. Looking at number 8, we want to find the geometric mean of each set of numbers, and we want to write them in radical form. So I'm going to scroll back up so I have some room. We're looking for the geometric mean. If you want to set up a ratio, you can, and then solve it so that you have x squared equals 100, and so then x would equal 10. So your geometric mean would be 10. That's one option. Or, that's part A. For part B, the other thing is to say your geometric mean is the square root of A times B. And so our A and our B are 3 and 60. And so I get the square root of 180, which is 6 square roots of 5 if you factor 180. Let's see, I'll do it over here. 180, we give you 2 and 90, 3 and 30, 3 and 10, and 2 and 5. And you've got a pair of 3s and a pair of 2s to make the 6. And then you've got the 5 that's left that goes inside the radical. Then the last one is 2.5 and 9.5. And so you can do it either way. If you want to set up the ratios, 2.5 over x equals x over 9.1, x squared. If you multiply those, you get 22.75, and then take the square root. So that would be your geometric mean. That's up to you how you want to do it. It really doesn't matter. But either way, you get the same answer. So now let's look at 9. So all of these are talking about the same figure. So let's look at A. If xw is 3 and wy is 12, we're looking for wz. So I'm going to label this x. Or, yeah, I'll label it A because it's part A. So now, when we go to set up our geometric mean, A is our altitude. So A is the geometric mean between these two numbers. So when you cross multiply, A squared equals 36, and take the square root, you get 6. So wz is 6. Looking at part B, we have wz is 4, xw is 2, and we are looking for wy. So I'll name it part B. So our altitude is the geometric mean, and our altitude is 4. So it's the geometric mean between 2 and B. So cross multiply and divide, which means that WY is 8. Looking at part C, they tell us XY is 22, so this whole part is 22, and then X to W is 9. So if I know the whole hypotenuse is 9, and this part, the whole part is 22, and this part is 9, that means that the rest of the hypotenuse must be 13. And then we are looking for WZ, which is our altitude. So we are looking for the geometric mean. So C is our geometric mean, and it's a geometric mean of 9 and 13. So then if you cross multiply, C squared is 117, and then take the square root, and you get 10.8. So WZ is 10.8. So now let's look at D. These pull in the second corollary. So XZ is 10, and XW is 4, and we are looking for XY. This time, we're using the leg. It is a geometric mean between the whole hypotenuse, which I'll call D, and the part that is adjacent to the leg, which is the 4. So if you cross multiply and divide, we get that XY would be 25. Looking at part E, WZ is 18, XW is 9, and we are looking for X to Z. So I'm going to label this part E. So when I'm looking for the leg is the geometric mean of the whole hypotenuse and this portion of the hypotenuse, because that's the adjacent side. We don't know the whole hypotenuse. We are going to be looking for it. So we don't know it, so before we can find E, we're going to have to find this part of the hypotenuse. So I'll label that X. So we know the altitude, and the altitude is the geometric mean between the 9 and the X, because those are the parts of the hypotenuse. So 9X equals 324, and then divide by 9 to get 36. So if I know that this is 36, I know that the whole hypotenuse has to be 45, because 9 plus 36 gives you 45. And so now I can find E. And I can say E is my geometric mean between the whole hypotenuse and the part of the hypotenuse next to the E, adjacent to the E. And so then when I cross multiply, I have E squared equals the square root of 405, I jumped ahead, 405, and then take the square root to get that E is 20.1. And so XZ would be 20.1 here. Now we've got F, part F left. And this is the one that's a little bit different. WZ is 4, and XW is X, and X to Y is 10. So on this one, we're looking for YZ. We're looking for this length here. But before we can find it, we're going to have to find the length of the longer part of the hypotenuse. So I know that the whole hypotenuse is 10, and I know this portion is X. So this portion is going to be 10 minus X. And so I can set up a proportion. 4 is my altitude. So it is my geometric mean between X and 10 minus X. And so if you cross multiply, you have 10X minus X squared equals 16. Since we have an X squared, we're going to want to factor this. So I'm going to make my x squared positive and move everything to the right side of my equation. So positive x squared, and then I have to subtract the 10x, and I have the plus 16. I'm looking for numbers that multiply to be 16 and add to be negative 10. So that's going to be negative 2 and negative 8. From there, set your two factors equal to 0, and then solve for x. So on this one, I get 2 and 8. And so I need to look at my figure. 2 and 8. If I let this be 2, if I let my x be 2, this length would be 2, and this length would be 8, which works in the problem. If I let my x be 8, this side would be 8, and this side would be 2, which is not at all drawn to scale. So we're going to keep the x as 2, and then that side length here is 8. That's what makes the most sense based on what we have. So from here, we can set up a ratio, and I'll say this is y. So y is my leg, so it's the geometric mean between the whole hypotenuse, which they told us was 10, and the part of the hypotenuse adjacent to y we just found was 8. And so then, cross multiply, y squared is 80, and then if you take the square root, y is 8.9, which means zy is 8.9. So that's how you would work through each of those parts. So now let's look at number 10. I'm going to erase some of this work so that we can see our figure a little bit better. Explain how the corollaries in this lesson can help us find the area of this triangle, and then actually find the area of it. So we know that area of a triangle is 1/2 base times height. We know that the base length here is 10 because it's 8 plus 2, and the corollary will allow us to find the height because it is our altitude of our right triangle. So we're going to label it x. X is our geometric mean between 8 and 2. So cross multiply, and then take the square root, and you get 4. So that means that our altitude is 4. So then using your area formula, area equals 1/2 base times height. So our base is 10 and our height is 4. And so then if you multiply, you get 20, and units are centimeters squared. So hopefully that helps you understand how you can use these corollaries with geometric mean. Personally, I feel like this is definitely the quicker option compared to what we looked at in the previous lesson. However, it does require some memorization. So I would encourage you to practice these so that you can do these more quickly and not have to go back and draw all of the 3 triangles.